Let me now provide some additional explanations on topic 2. As we have gone through topic 2, we have focused on programming techniques. But since we chose cryptography as a practical application example, it would be a waste not to talk about modern cryptography. So we will study this a little bit. To start with, I would like to talk about the evolution of cryptography, and in particular, public key cryptography, which has become widely used in recent days. In the end, I will also tell you about the safety of cryptography as a summary of these additional topics. Let me first talk about the evolution of cryptography. In the last session, we used the encryption method called the Caesar cipher, which is said to have been used by the Roman Emperor Caesar. This was a very simple encryption method, and in fact, we were able to break it easily. That is, the cryptanalysis was not so difficult. Since then, cryptography has made much progress and have become much stronger. For example, Enigma, the method which the German army has used during World War II, was considered to be very powerful cryptography. However, even that was cracked. In this day and age where we have much more powerful computers, the need for even stronger encryptions have also become greater. In recent days, the encryption methods called DES, and EES have become quite common. But these may be enough. These may not be enough in future. In these developments, cryptography has got stronger and stronger. In the world of cryptography, the strengthening of encryption and cracking of those codes have become a game of cat and mouse. Besides these, another stream has appeared that is a new form of cryptography. Actually, these cryptographies are all based on a scenario called private key cryptography. It is also known as common key cryptography. Against this backdrop, a new encryption method called public key cryptography has emerged in the 1980s. Let me introduce you to this method. Let me first talk about the private key cryptography. Cryptographic communication is like placing a document you wish to send in a box and putting a key on it and then sending it. Therefore, those without a key are unable to open it and see what is inside. This is how it works. The conventional cryptography, known as private key cryptography, is an encryption method in which the key used to close is the same as the key is to open. They are the same. So between the sender and the receiver, there is an agreement to use a common encryption and decryption key for carrying on communication. For example, Mr. A and Ms. B decide together how to lock their encrypted communications. That is a basic format. In contrast to that, the public key cryptography uses a different key for encryption and decryption. That is to say, the key that is used to lock and the key used to open the box are different. This is crucial in the public key cryptography. Furthermore, in the public key cryptography, while the key to decrypt must be secret, we can make the key to encrypt public. Let me explain how it works. We once again start explanation with the conventional private key cryptography. With private key cryptography, Mr. A and Ms. B agrees with one another to communicate using this key. So for sending a message, Mr. A puts the message in a box and lock it as a ciphertext and send it off to Ms. B. Then Ms. B uses the key to open the box and read the message inside. This common key should be secret between Mr. A and Ms. B. On the other hand, in the case of public key cryptography, two different keys are used for encryption and decryption. If Ms. B would like to have an encrypted message sent to her, then Ms. B will tell the sender that she would want the sender to use the particular key, this encryption key. Then, using the key, the sender will put the message in the box and lock it and send it off to Ms. B. Then Ms. B will use her key to unlock the box, meaning the decryption key, which is different from the key used to lock the box and see the message inside. The key can be used not just by Mr. A, other people can use the same key. For example, Mr. C can use the same key to encrypt or lock the box and send it off. Then Ms. B can use her decryption key to open the box as before. Note that only the key to open the box should be kept secret, and it is secret key for herself only. On the other hand, the key to close the box can be made public. That is, while the decryption key of her is her own secret, the corresponding encryption key can be public. And it is okay for anybody and everyone to know her encryption key. So everyone can send an encrypted message to Ms. B using her encryption key. This is the gist of the public key cryptography. Let us consider what is good about this method. In the public key cryptography, each person creates a key for other people to send them a ciphertext and makes that matter of public knowledge. For example, Mr. A, Ms. B, and Mr. C. Everyone would say something like this: when you send something encrypted, please use this key of mine. What is good about it? By this method, many people can use the same key to send encrypted files to, for example, Mr. A. In other words, in the case of private key cryptography, there needs to be different common keys for each pair of communication. For example, between Mr. A and X, Mr. A and Y, Mr. A and Z, and so on. However, in this case, keys need to be made for each recipient, and anybody can use it. This is a very important point. In other words, you will be able to have encrypted communication with an indefinite number of people. This type of encryption is said to be very useful in the era of the Internet. For example, in online shopping, let us consider crowd shop A, B, or C instead of Mr. A, Ms. B, and Mr. C. Each shop, such as shop C, can request to all to use a particular key to have the ciphertext created when sending anything over. This is what it can do. For example, it is used to request customers to encrypt their credit card number. In fact, when you are shopping online and when you send your private information, what is happening in the background is the shop's computer sends such a key to your computer, and your computer sends back your private information encrypted by this key. There is another important application of the public key cryptography. That is what is known as digital signature. Let me give a brief explanation about this. Here again, the feature of the public key cryptography is important. That is, encryption key is different and is from the decryption key. They are not the same. The encryption key can be shared with everyone, while the decryption key should be kept as your own secret. For example, suppose I have some important document, such as a release agreement of a sort, stating I borrowed this thing and I shall return this by a specified date. Usually, for this kind of document, we necessitate for a signature. In Japan, we would usually use a hanko, a seal. Anyway, this acts as a guarantee that this is a document that I have produced. How do you deal with this over the Internet? Of course, you could use your seal or signature and scan it and send it over. But there is a way that would guarantee that you are really the person who sent this message. That is what digital signature is. So how do we actually do this? Let's assume I, Mr. W, is using some public key cryptography, and I have my own pair of encryption and decryption keys, like these. And we have this document as a file message.txt. Now I forcefully decrypt this by using my own decryption key, QW, this QW. You may be confused to hear this. I understand this. Recall encryption and decryption. The decryption is an act to restore an encrypted ciphertext to the plain text or the original message. So the decryption or the function dec is applied to a ciphertext that is obtained by the encryption function, not a plain text like this. Anyhow, let's apply this decryption function on a message.txt with my own decryption key. This will produce something. You don't know what will show up. But then, if you apply the encryption function on the obtained string with my encryption key, PW, you will get the original message. The original document will appear. Let us think about how that happens. Well, let's ignore the meaning of these M and C. Just think of them as strings. Then application of these functions can be seen as transformation from M to C and C to M. So if you apply the function dec to the string C, you would get the string M. Then if you apply further the function enc to this M, you would get back to the string C. Mathematically, the function dec is the inverse function of enc, and symmetrically, enc is the inverse function of dec. That is why the original message is obtained by applying function enc with the encryption key. We can use this mechanism to implement the digital signature. Let's think about this system. For a document like this, for which I would like to have it signed, I prepare a file obtained by forced process of decryption with my decryption key. I would claim this file is my signed document and pass these two files, that is the original document file and the signed document file, to the person, say Mr. H, who needs this document. If Mr. H wants to check the signature, he only has to apply this encryption function with my encryption key. And if this yields the original message, then he can be sure the correctness of the signature. Why? First of all, if I made this signed document correctly by applying the decryption function with my decryption key, then original message must be obtained by applying the encryption function like this. Recall that this decryption key is my own secret. That is, no one but me knows this key, so only I could make this signed document. That is why Mr. H could be sure that this is my signed document. Note also here that my encryption key is public. Therefore, Mr. H also can use it for his confirmation process. Finally, let me briefly discuss the safety of cryptography. The question is whether cryptographic communications are in fact safe. That is to say, what is the chance of having your ciphertext deciphered? The answer to this depends on whether the method used is based on private key cryptography or public key cryptography. In the case of private cryptography, you will be safe as long as nobody guesses the encryption key. as long as the common secret key held by both Mr. A and Miss B is not guessed by an eavesdropper, then you are safe. To avoid having that key guessed, the less ciphertext and plaintext there are, the safer it will be. For example, in the case of the Caesar cipher, it doesn't take that many pairs of ciphertext and plaintext to crack the cipher. It is such that as the more complex and powerful the ciphers become, the more pairs you will need. Of course, the key management is important. Even if you use a very strong cipher, it is not safe at all if your secret key is revealed. On the contrary, so long as the information of your key is not leaked, encrypted ciphertexts are completely safe. This perspective is called information theoretic security. On the other hand, what about public key cryptography? Public key cryptography uses an encryption key that everyone knows. So that means if you want to decipher a given ciphertext, for example C, then this is theoretically possible. Here is the way. You try all possible plain text and encrypt them to generate ciphertext. Then eventually you could produce the same ciphertext by which you would know the original message. For example, suppose some CI is indeed this C, then MI, that is the plain text that produces this CI, must be the original plain text corresponding to the ciphertext C. This method is called exhaustive search. Well, the exhaustive search is theoretically possible, and some computational wizard like him may achieve this. But the exhaustive search needs an enormous amount of time because there are a huge number of candidates. And it is practically impossible, even with a very powerful supercomputer. So in the public key cryptography, while deciphering is mathematically possible, practically it is not possible at all. More precisely, public key ciphers are designed so that there is essentially no other way than exhaustive search for cracking, and that they are secure because it takes huge amount of time for cracking. In this sense, this type of cryptographic security is called computational security. Let me summarize additional topic. We studied modern cryptography briefly, which plays an important role in the Internet society. There are two types of cryptography. The standard one and conventional one is the private key cryptography, or the common key cryptography. This has a long history, and their strength has been evolved with each stage. We can expect that it will continue to evolve in the future. Another one, which was invented in 1980s, is the public key cryptography. This type of cryptography is useful in the era of Internet. For example, by using the public key cryptography, we can give a signature to a document digitally. We better remember that their security is guaranteed only from computational viewpoint. Their security is guaranteed based on the computational hardness of cracking.